Hello, today we are going to discuss the fundamental theorem of arithmetic. In particular, we will prove the uniqueness of prime factorization. Let us begin with the definition. A prime number is a natural number greater than 1 that has exactly two positive divisors that are 1 and itself. The theorem, the fundamental theorem of arithmetic, states that every integer greater than 1 can be written as a product of primes, and this representation is unique up to the order of the factors. Before we prove the theorem, we need an important result. This is known as a Euclid's lemma. Let us write it. The lemma states if a prime number p divides a product ab, p divides ab, then p divides a or p divides b. We need to know this before we prove the above theorem. Now, let us prove the uniqueness. Suppose that a number n has two prime factors. Let us write n as a product of primes p1, p2 up to pk, and n equals q1, q2 up to qm, where all pi and qj are prime numbers. Since p1 divides the product of qi's, you know that it divides n, where n equals q1 times q2 times up to qm. So, by Euclid's lemma, p1 must divide one of the qj, but each qj, p1 must divide qj. But we know that qj's are primes. So this implies that p1 equals qj. We can now cancel this common factor. Repeating this argument, we match all prime factors. Therefore, both factorization consist of the same primes. Up to ordering, this completes the proof. This result shows that prime numbers serve as the fundamental building blocks of integers. Thank you for watching and subscribe for more videos.